Assalamu alaikum. I am Sumbul Zehra, lecturer in physics at Sir Syed Government Girls College. Today we will study what is resistivity. This is my 30th lecture of this series, and this would not have been possible without the support and guidance of our honorable principal Professor Khalda Parveen. Now coming to our topic, which is resistivity. We know what is resistance. Now we will see another characteristics, that is resistivity. What is the difference between resistance and resistivity? We will see it mathematically. First consider there is a conductor. This conductor has got certain resistance R. We are changing certain changes to this conductor. Suppose we have taken double of the length. For example, if we increase the length of the conductor, what happens to resistance? If length increases, we will see that resistance also increases. We did another thing. We increase area of cross section, that is thickness. Area increases, we find that resistance decreases. If area increase, resistance decrease. If length increase, resistance increases. So now consider it mathematically. Resistance is directly proportional to length. Resistance is inversely proportional to area. So R is directly proportional to L and R is inversely proportional to area A. Now combining both these equations, so R is directly proportional to L upon A. With length, resistance increases. With area, resistance decreases. Remember, this is a thumb rule. If we made equal, we must introduce a constant. So equation becomes R equals to rho L upon A. Now what is the rho? This is a constant. If it is a constant, so let's study its characteristics. So rho is equals to R A upon L. If area equals to 1 unit, length equals to 1 unit, then rho equals to R, which is resistance. That means rho is the resistance of the conductor if area is taken as 1 unit and length is also equal to 1 unit. Then resistance is constant, which is rho. Now question is, what is the difference? The difference is resistance will increase with the length. It will change with the length and area. Here length and area we made it constant, that is 1 and 1. So rho is equals to R, where R is the resistance. So we change the name little bit and we call it resistivity. Now what is the difference between resistance and resistivity? So answer is resistivity is the resistance when length is 1 unit and area is also 1 unit, and resistance is depending upon length and area, but both of them are resistance. So resistivity is a special case when both length and area are 1, and capital R, which is resistance, is the resistance of the total, whatever is the length, whatever is the area. But now when resistivity is changed, when we have fixed length 1, area 1, we are not changing length, we are not changing area, this becomes a constant. But if we change the material, we find this value of resistivity is different. Again change the material, the value is different. So this is property or characteristics of a material. When we change the material, resistivity changes. So we call this also resistivity as spatial resistance. When we use the word specific in physics, when any characteristic is related to a unit, whatever unit, then we use the word specific, like specific gravity, specific heat, or specific heat, specific gravity. So both are related to 1, 1 and 1. This is a spatial resistance. If length is 1, area is 1, then the resistance will be known as specific resistance. This is the property of different material. For different material, this value will be different. So we call it resistivity of the material or resistance of the material. Now, coming to the units of resistance and resistivity. Unit of resistance is ohm and unit of resistivity is ohm meter. Now, dimension of resistance and resistivity. Resistance has a formula R equals to V upon I. V is equals to work done per unit charge into I. So, work done upon charge has a formula I into T. So work done per I square into T. So work has a dimension ml square T minus 2 into T upon A square. So resistance has a dimension ml square T minus 1 A minus 2. Now dimension of resistivity, which is rho equals to R L upon A. So rho equals to m L square T minus 1 A minus 2 into L upon L square. So rho equals to m L T minus 1 A minus 2, which is the dimension of resistivity. Right. So that's all for today. Thank you so much.